Hello, welcome to section 7, part C of the SAS programming course. We start right away where we left in the part B. There we were, or we had already done this scatter plot, and the idea was that we were interested in looking into the distribution of yield variable and compare how it looks for different location and fertilizer groups. And we had already drawn a few versions of the scatter plot to do that. But next we would be interested in calculating the same kind of information using descriptive statistics. And that can be done using the proc means, and the subgrouping can be defined both by using either by or class statement or comparing the use of them both at the same time, which is done here. One thing to notice, however, is that if we are using the by statement, as we do for location here, then the dataset must be sorted by the same variable. So when we have by location here, we must have a proc sort with by location preceding that. Or another alternative is if the data is already sorted, then we of course do not have to sort it again. But so we sort by location here, we save the output as x2 and take it into the input here in the proc means. Then we define that we want to calculate statistics from yield variable, and we want to do it by location, and in the class statement we have fertilizer. So in essence, for each location and fertilizer subgroup, you could use only class statement or only by statement just as well. But by doing it this way, by statement makes it so that we get a separate table for each by group, so for each location, and class statement on the other hand makes it so that we get the groups as different rows within the same table. But here we see that that in location 2, which was maybe a little bit less clear from the scatter plot, we see that fertilizer 2 and 3, they have a little bit higher mean than fertilizer 1, and the mean level is quite different. So in location 1 they are much higher compared to location 2, and there fertilizer 1 is highest, 2 is lowest, and 3 is in the middle. And standard deviations are maybe roughly the same size, some variation there too. Again, here we can also calculate the same descriptive statistics by using proc univariate like we did earlier, and we can do that also by subgroups. And we can also use the normal and plot options to add tests of normality and distribution plots. By statement is used here instead of class statement for subgrouping, mainly because that gives us a nice box plot combining all the groups in one image. So that's why we use the by statement. And again, when we are using the by statement here in the proc univariate, we must make sure that the data is sorted accordingly. So that's why we have a proc sort with exactly the same by statement here first. And then in the proc univariate, everything is pretty much familiar to us from earlier examples. So output looks like this. We have only picked the box plot. There would be pages and pages of output because it gives the same long output with a lot of descriptive statistics for each of these 6 subgroups. But I just picked only the box plot to show because that gives us a good overview on how things look like. We see the same we saw from the descriptive statistics, that clearly now the location 2 is lower on average than location 1. But maybe the main that's actually the main thing we draw from here is that roughly the variation is similar in each subgroup. Biggest differences between locations, and then there is some slight differences within location between the fertilizers. We can also use a specific graphics tool to draw the box plots just as well. The previous one came from Proc Univariate with a lot of other output, but we can also use VBox or HBox statements in the SGplot to do the pretty much similar box plot. So here we are saying that we want to draw a vertical box plot from variable yield, and there's 2 places where we can specify the grouping variables. So we specify location in the category option and fertilizer in the group option. And output looks like this then. So locations are location 1 is here on the left side, location 2 on the right side, and then each fertilizer is presented with a different color box plot. But of course, the conclusions we draw are the same as earlier. Often it's also necessary to save the output of these descriptive statistics procedures to a SAS dataset. And so, for example, we might take several measurements for each experimental unit or statistical unit, and we would actually like to calculate the mean out of those observations and use that averaged data as input, for example, in some further analyses. And this can also be done in the means procedure or univariate procedure using the output statement. In this case, we also, again, like earlier, we have the proc sort here first. So we sort by location and fertilizer. If we have a by statement later, and here we actually see the by statement, that was the reason for the sorting. And now we are calculating again the descriptive statistics from the yield variable by location and fertilizer. And in the output statement, we now define that the created dataset will be called means1. It will go to work folder because there's no library reference defined here. And then in this mean option, we are saying that we want to save the calculated means into variable called yield underscore mean. And in the STD, we are saying that the standard deviations will be saved into variable called yield underscore STD. And then there is also this no print option, which makes it so that the descriptive statistics table will not be created in the output window, but only the SAS dataset is the only result we are getting. And here a screenshot from SAS Studio shows us what it looks like. So we have each location fertilizer subgroup, and yield means and yield standard deviations are here in their own variables. Okay, and of course we can do the same also by specifying the subgroups in the class statement, like we have here. Earlier we had by statement, but we can also use class statement. Otherwise, this is pretty much the same, but the printout is now a little different. So when we do the subgrouping in the class statement, it also counts as these other sort of groupings. It will give us a grand mean, so mean and standard deviation out of all 175 observations. It will give us a fertilizer group means over each location, and it will give us location means over each fertilizer, and then these last 6 rows are the same we saw earlier. So sometimes it might be useful that we have these different groupings all here together. But if we would only like to have the 6 subgroups, then we can prevent the other groupings using this n-way option as we have done here. So otherwise, this is the same code, but the n-way makes it so that we only get the 6 location fertilizer subgroups in the output data. Yeah, thank you.